विच ऑक्सीडेशन नंबर ऑफ 2+ का कलर कैसा होता है? तो गुड इवनिंग स्टूडेंट्स, आपको जैसा कि पता है एक्सपेरिमेंट में सबसे पहले फर्स्ट ऑफ ऑल आपको एक्सपेरिमेंट करना होगा टाइट्रेशन का। टाइट्रेशन के एक्सपेरिमेंट में आप नोन सॉल्यूशन को यूज करके और डिटरमाइन करेंगे KMnO4 जो अननोन सॉल्यूशन है उसकी स्ट्रेंथ को डिटरमाइन करेंगे। तो इस एक्सपेरिमेंट के लिए आपको फर्स्ट ऑफ ऑल स्टैंडर्ड सॉल्यूशन प्रिपेयर करना होगा और ये हम करेंगे फेरस अमोनियम सल्फेट के साथ में। इसके लिए हम आपको एक्सपेरिमेंट करके डिमॉन्स्ट्रेट करके बताते हैं। फर्स्ट ऑफ ऑल हम टाइट्रेशन के लिए नोन सॉल्यूशन जो यूज कर रहे हैं फेरस अमोनियम सल्फेट का करते हैं और इसके लिए हम एज्यूम करते हैं इसके लिए स्ट्रेंथ m/10 मोलरिटी m/10 और इस फेरस अमोनियम सल्फेट के 250 ml स्टैंडर्ड सॉल्यूशन को प्रिपेयर करके देन वी डिटरमाइन द स्ट्रेंथ ऑफ अननोन KMnO4 सॉल्यूशन। तो लेट्स स्टार्ट। फर्स्ट ऑफ ऑल वी measure the amount of ferrous ammonium sulfate which is used to prepare the m/10 250 ml standard solution of ferrous ammonium sulfate. We know the formula of molarity, that is equal to number of moles upon volume of solution per liter, in which molarity is 1/10 which is placed and moles is calculated as weight upon molecular weight। बच्चों फेरस अमोनियम सल्फेट फार्मूला है FeSO4.NH4 whole twice SO4.6H2O which has molecular weight 392 gram, and so when we calculate the amount of ferrous ammonium sulfate from the molarity formula we put here as in copy or board, that is 1/10 is equal to number of moles upon 250 ml which is calculated in liter, that is 250 upon 1000, then 1/10 is equal to W divided by 392 into 250 और इसको 1000 से डिवाइड करेंगे ताकि लीटर में कन्वर्ट हो जाए। इससे आप कैलकुलेट करेंगे अमाउंट ऑफ फेरस अमोनियम सल्फेट एंड इट इज कैलकुलेटेड एज 9.8 ग्राम। सो फर्स्ट ऑफ ऑल वी वे 9.8 gram of ferrous ammonium sulfate in weighing machine. For it we put the watch glass in weighing machine and in it ferrous ammonium sulfate is added which is to weighted at 9.8 gram। और अब हम इस वॉच ग्लास को वेइंग मशीन से बाहर कर लेते हैं। आफ्टर देन लेट्स स्टार्ट दिस प्रिपरेशन ऑफ स्टैंडर्ड सॉल्यूशन ऑफ 250 ml of ferrous ammonium sulfate m/10 strength। then first we use, this is called titration flask or volumetric flask. In it we prepare 250 ml standard solution because this is also the measure the 250 ml standard solution which is seen by the indication given in it. Then we use funnel and in it we add ferrous ammonium sulfate properly no particles of ferrous ammonium sulfate remains on the watch glass. After then we add distilled water in it through the funnel slowly and in the walls of funnel. Then after distill water in watch glass so that the remaining particles of ferrous ammonium sulfate which is attached with watch glass that draws into volumetric flask. After then we stir it, that's why ferrous ammonium sulfate particles dissolve in distilled water. some amount of distilled water is also added in it. We stir properly and seen on the bottom side that the solution will be clear. You saw that the all particles of ferrous ammonium sulfate dissolved in distilled water, and then with help of funnel we add distilled water through this mark which represents the 250 ml solution. distilled water इसमें you see that all the particles of ferrous ammonium sulfate dissolves in distilled water completely. You see that the distilled water reaches on the indication, and this is the standard solution of M/10 ferrous ammonium sulfate 250 ml. After the preparation of ferrous ammonium sulfate standard solution, you see that this solution must be clear. If it becomes green, it means that ferrous sulfate oxidizes into ferric sulfate, and so in that case no required testing is done for the titration of KMnO4 and ferrous ammonium sulfate whose strength is calculated. So this is the standard solution of 250 ml, standard solution of ferrous ammonium sulfate. After then we use conical flask, pipette, and this pipette is of the strength of 20 ml, which is also seen. You see that the 20 ml ferrous ammonium sulfate standard solution is taken in pipette, and this solution is transferred into conical flask slowly, and remember that this solution does not strike with wall of conical flask. You see that all the 20 ml ferrous ammonium sulfate standard solution is transferred into conical flask with the help of pipette. Now in it, the standard solution of ferrous ammonium sulfate, we add the dilute sulfuric acid, half of test tube. So that's why the ferrous sulfate present in ferrous ammonium sulfate is oxidized into ferric sulfate, and so with the help of this solution we determine the strength of given unknown KMnO4 solution. You see that half of test tube of dilute sulfuric acid is transferred into conical flask in which a standard solution of ferrous ammonium sulfate is taken, and now it will shaken properly, and after then we use stand burette. In burette we fill the KMnO4 solution of unknown strength. This burette is of strength of 50 ml, and in it You know that in conical flask we use the ferrous ammonium sulfate of standard strength, that is m by 10, which is known, and we determine the strength of given KMnO4 unknown solution with help of this experiment. And now this conical flask is put here on stand, in which we add KMnO4 unknown solution dropwise into conical flask in which ferrous ammonium sulfate is taken. Remember that, or it is precaution that no drop of KMnO4 solution attaches with wall of conical flask, otherwise reading will unmatched. And this KMnO4 solution dropwise added in standard solution of ferrous ammonium sulfate, and the point at which this standard solution of ferrous ammonium sulfate becomes pink nahi, light pink, then that is the final reading. So we add the KMnO4 solution dropwise in standard solution of ferrous ammonium sulfate. You see that KMnO4 drop, when added in ferrous ammonium sulfate, this solution becomes colorless and it reaches at a point at which this solution becomes light pink. That is the final reading at which this solution becomes light pink, in which potassium permanganate, you know that the formula of KMnO4 is KMnO4 potassium permanganate, in which oxidation number of Mn is +7, and you add the dilute sulfuric acid in conical flask. You know that KMnO4 reacts with this solution in acidic medium, and in acidic medium oxidation number of manganese reduces its to lowest oxidation state, that is +2, and the solution MnO4 minus, representation of KMnO4 solution is MnO4 minus, and it converts into Mn2 plus. You know that Mn2 plus forms at a point at which this solution becomes light pink. You know that in D and F block chapters that Mn2 plus, that's configuration is 3D 5 4s2Mn, and Mn2 plus is configuration 3D 5. You know that 3D 5 D5, that is 5 unpaired electrons are present in manganese atoms. In it we add dropwise KMnO4 solution. This is the at 4.6. It is the reading of KMnO4 solution, in which when we add 4.6 ml of KMnO4 solution in standard solution of ferrous ammonium sulfate, this solution becomes pink in color when 4.6 ml of KMnO4 solution is added in conical flask in which ferrous ammonium sulfate is taken. So this is the final reading 4.6. You see that this becomes light pink, this, and this is the reading of KMnO4 solution. After then when we calculate this reading into 2 times with the help of ferrous ammonium sulfate, then we determine the strength of KMnO4 solution, that is formula M1V1 is equal to M2V2, and after then when we calculate the number of moles and when it is multiplied by molecular weight of KMnO4, that is 158, and then we determine the strength of KMnO4 solution. कलर कैसा होता है